Hi, you are live. It's saying excellent connection. That's useful. Oh, wait. I am actually live. Hi. This is awkward. Hello. I thought actually that I had a couple of extra minutes in the background to kind of figure things out, and then it just kind of popped up and said, "You're live." So here we are. It's really nice to be here. I haven't been live on camera since about February this year, so little bit of a little bit of a break. I'm a little bit rusty, you might say. Yeah, there's a point. Sorry that the and hi from Sweden and hello from the UK. I really hope that you enjoy hanging out for a little while. More than happy to answer any questions or just kind of chat casually, whatever you would prefer. I have an editor available. It's kind of customary when one is on a live coding session, but we don't have to do that. Anyway, so I'll just start off by compiling some code. And it's really nice to see some familiar faces. So, uh, so let's start off like, well, how? Oh, we. This is the wrong place to start with a build error. I wonder if I can make things a bit bigger. And I will increase the integrated file. I might change this. I need to jump around a couple of things. I will make myself smaller. There we go. And now you should be able to see what's happening. So where am I? The terminal is up a little bit. I need to go into the cargo project. And so I thought that I would have some questions if I run cargo build. Actually, I'll run cargo run and I'll add the -q flag for quiet. I should get hello YouTube. And I can't spell online, which is useful. Okay, right. Okay, so we have some questions. And I am just we've got a really easy one. He says. Okay, so the first question is hello, I'm struggling to learn about what RC F cell usage is. Now, this is. Could you move it to the top right? It's currently. Sorry, there's a question. Can you move your terminal, your picture to the top right? It's currently obscuring the terminal, which is a good thing to change. Unfortunately, I'm using this horrible system that instead of like a manual streaming thing, it's got a fixed layout. What I'm going to do is change it so that I'm here. And then I'll increase the size of the. I could even just remove me. No, I'll keep myself on there. And I'll go back to the settings and we'll just increase the size a little bit so that they are things can be seen. Okay, 34 for the font size, and the integrated terminal, add that up to about 30. Maybe that's too large. Maybe it's not. We'll find out. You can complain. Hello, I am just struggling to learn RC RefCell, and then there's probably a T in here as well. And the first question is like, what on earth is going on here? So, if I enter the standard library, I can use standard, let's say sync RC and RefCell. Inside the sync module of the standard library, I have got these kind of two types that are confusing. So, RC stands for reference counted, counter or counted. So, and what this will enable me to do, and there's also this ref cell thing. and I will explain. Let's explain what the term reference count is. And ref cell doesn't really need explanation as it is. Oops, sorry. Just got the keybind in here. Now, unfortunately for the naming, reference is actually being used. It's one English word, but it's representing two distinct types of references. Ideally, these references over here would be would have some would be different to the references here in RefCell. This RC thing is trying to provide a count of the number of times that ownership, has been moved or kind of used around. So let's try if I create some sort of struct that I care about, and I want to create a shared access to it, but I don't want to be able for it to be destroyed until everyone is finished. Let's say that I might, want to access multiple threads. By the way, I'm probably going to get a few things wrong as I talk, because I am quite literally doing this live. So the so we'll see. And there have been a couple of other things about RC is not sync and so forth, and we'll see where we get to. I'll pull across so that we're not losing anybody. I will try to pull, sort of refer to this standard libraries documentation. So if we go to docs.rustlang.org into stud, and I'll change the thing so that we're dark, so that you don't get blinded, and then look for ref cell. It's in standard cell, so that's odd that it came through. So that was actually the wrong place. And I think RC, that was let's search for RC. Standard RC is also in RC, which is also not in sync, which is kind of weird that the autocorrect actually worked. Sort of the autocomplete. I suppose what's actually happening is that the autocompleter discovered, it did the tokenization on these two bits here, and then just kind of didn't correct me because I haven't actually tried compiling anything. So let's see if I can get this to work. It will blow up on me potentially. The RC provides a single threaded reference counting pointer. This is what, and so we can actually have a shared object for any type T. And in our case, I want to create an API, but the standard libraries documentation is got a number 5. Oh. Copy and paste failed me. The API is, let's start with RC, and the constructor there is new. And I've got an API which I'll initialize just kind of with the literal syntax because it's a bare struct. And just to be, I'll just derive debug. Now I'm surprised that I haven't actually got a little bit more help from the from Rust Analyzer. I mustn't have configured everything correctly. Although Rust Analyzer down here is actually telling me that it's happy, so whatever. So we're okay. We've got a couple of warnings, but we're actually moving forward. And then examples with So the question, by the way, is we're trying to learn about RC and RevCell and why we need both of them together. It turns out that they provide different things. RC provides reference counting, which means that we know how many references into an object we have. And the second actually provides machine ownership. And the distinction between those two, or why they need to operate differently, is because Rust provides you a lot of control over how, well, the kind of semantics that you actually want from your programs, because we can mix and match them however we want. And RC is going to, or where's a more interesting example. Oops. Let's create some references to our API. So I've got caller one, and I'm just going to sort of say API clone. And this looks really odd, or at least it did to me. When I first started programming in Rust, I thought it was very strange that clone existed in multiple places. And the reason why it's used, the reason why it's clone is we are cloning a reference, not the object. And when we clone the object, when we clone the reference, what's happening is the implementation of the trait that enables it to, the implementation of clone actually increments the counter. But there's no explicit like free or destruction, and that's because it's actually provided with the drop trait. So it's this kind of interesting, call one API. Now, so you can clone this as many times as you want, and let's inspect the internals of this API thing, because its state is going to change while we actually manipulate it. So caller one. So our central, what we're trying to achieve here is creating a central API. We actually want to get into the reference count. We want the reference. The problem that we're facing is we don't care about the struct. And it's going to give us information about the struct. So what we actually want to do is inspect, count how many references there are inside inside this API object. And notice, by the way, that it is an immutable reference. That's kind of like something to think about as we're kind of going on. So at first, it looks very boring. Our API object, the API variable, looks exactly the same as these callers, but actually they are slightly distinct. Now, to get to the internals, we need to have a look at the documentation and find some of these methods that I might have and see if we can actually find the counts. Or can we, the problem that we face is that if you look in the documentation, everything sort of says private fields. If I go into the source, I bet there's some there's some null pointers RC box thing, some phantom data. That's kind of scary, but what that means is that there is some stuff there that is being manipulated, and we want to get at the data. Okay. Conrad's just provided some really useful information, which is that Rust Analyzer is going to have difficulty finding this this questions thing because it's in the wrong directory. So if I move source into main, I move everything into main. Sorry, I just derailed myself. Did I mean run? Okay. So I'm just going to delete this questions directory. And then hopefully, oh, that was poor form. I deleted all my settings. Oh gosh, that was embarrassing. Open the workspace settings, and then I need file size. Sorry, I'm just, hopefully you can hold into your brain that I am actually trying to answer this question around RC and ref counting. This is not the fastest way I've ever been online before, but hopefully you will forgive me. Okay, now right. And I've just, yeah, like forgotten that actually, because I'm actually inside Visual Studio Code, it provides me like with an undo for delete. It's not like as if I actually ran RM inside the shell. Okay, so where was I? I was trying to talk a little bit about RC. We want to get into the number of counts, and I wonder if we. This is probably like a silly thing to do, but the intuition we want to get is that we are doing something as we clone an API. The API is changing, even though it is an immutable value. Now, is there strong count? There is strong count. This is what I. Yeah. Okay. Great. Notice that it isn't actually a method of the type. It's not an inherent method. We need to go in and actually that might not be true. It might provide us with a it might provide the API, but it's not very good practice to actually call the methods on RC. I've kind of been cheating a little bit, and I wanted to tell you about that later. Oh, okay, these are not associated functions. They are actually, strong count is actually a free function that exists inside the RC. Well, it's a static method of the RC type, and that doesn't have self. So I actually need to take a reference to an object. This is done, if you're an API designer, you might do something like this because you don't want to kind of get it abused or make things confusing. The argument is never used. Format specifier missing. Oh, I see. Sorry. Sorry, code. I need to delete this. Oh, gosh. Clear, run. Good, good, good. We're at 333. That's weird. Ah. There's very little point in me checking the count as we go. What about now? 1, 2, 3. There we go. Okay, so we have this kind of weird problem where we are changing internal state even though we have an immutable reference. So this doesn't actually, so this is confusing because if you've, this is an instance of what is known as interior mutability. Interior mutability creates this facade of immutability, but it enables types to change or alter their interior state. It turns out that all interior so it's this kind of this feature. It actually exists within the standard library rather than within Rust itself. It's kind of a cheat. Uh, People, I know there are some colleagues of mine who don't like the term immutable value. They prefer the term shared reference. And the reason is it's confusing because these shared references, the let bindings, can actually change because of immutability. All interior immutability is provided by these by this thing called unsafe cell. Unsafe cell has the kind of crazy ability to be able to provide an immutable facade, even though the interior is changing, because it can guarantee so that all references will stay in the same place. So Rust is actually providing a different guarantee to the compiler than you might think. We talk about mutability and immutability, but in Rust, what we're really interested in, or at least the Rust compiler is very interested in, is guaranteeing that aliasing is very, very, what's the word? Very precise. Rust will not allow two references to refer to the same position in memory, or that both believe that they have the ability to mutate a value. So you can't take two mutable references to the same object, and that is known, and if you have two pointers that refer to the same place in memory, this is known as aliasing in kind of the computer science terminology or literature. And so what the Rust compiler is providing is this guarantee that ampersand mute Rust is sort of say these mutable references. There can only be one at a time, whereas a shared reference or an immutable reference is multiple, or we can have as many as we want. Now this presents a problem because of RC's semantics. We need an extra guarantee that the reference counting and the shared mutability semantics are going to play nicely together, especially if Rust wants to make guarantees about multi-threading. By the way, in case anyone has just joined us, I'm spending a tremendous amount of time explaining RC and then this idea of RC and wrapping ref cell and T. So why, if you are taking references, do you want to wrap a ref cell? So you can think of T instead of just creating a reference counting of an object itself. And the reason why, oops, I just lost my browser. Let's read ref cell. It enables dynamic checking. So this is providing, what it's actually providing is a shared ownership. So you can see here that this documentation is actually discussing the same thing that I just mentioned about these two about Rust's memory model, but we we can kind of get around it. This is basically providing a cheat, and that is the type is telling the Rust compiler that it is following the rules. But actually, under the hood, if you go and look at the implementation, it's using unsafe and is cheating. But it's enforcing the same semantics at runtime, so it has runtime checks. And so each of these references is, so what have we got here? We've got a lot of noise. We've got our shared thing that we are trying to protect, or at least we've got our shared, we've got some external resource that we want to, that might be expensive to create. So it might be a database connection, but in our case it's an API. So we've created a TCP connection and we've authenticated with an external API, but we only want to do that once. And in the rest of our program, we've got two instances. We've got two places in our program where we want access to that API. Both of those variables, let's say caller 1 and caller 2, believe that they are the owner of the API. Now, this is a problem because actually all they are doing is they've just got references to this, to the API itself. Now, the rev cell provides kind of just the extra. It's hard to explain, just kind of over the top. It just it provides just an extra. A bit of correctness. I'll think of a better way to explain this. But I would recommend, I'm going to just copy this into the chat, that you spend a little bit of time kind of going through this and figuring it out. And I'm also going to drop in the documentation for reference counting. No, it's not. Cool. Now, I'm sorry, I got a little bit muddled at the end there, but what we're actually providing is, so the problem, I'll just try it once more. The reference counting is useful. We know how many references that we have, but it doesn't mean that it doesn't provide either of these two variables kind of with the ownership semantics that they would like. And that is what the ref cell provides. Okay. Oh, cool. I have spent a little bit of time trying to answer that question. Gosh. I thought this would only be sort of 45 minutes. We can, and so I've kind of like almost reused half. How is everybody doing, by the way? I thought I should check. I'll just look for the next question. Okay. There's actually a really interesting point. We had a comment but I skipped it. Just saying, why didn't you implement the drop trait yourself, and then we could see its semantics? And in fact, that's a really neat idea. What we would end up doing though is basically implementing all of RC ourselves. So that's actually something that you can do. You can go and implement a type. The standard library should not feel too magical to you. And always feel comfortable going and opening up the standard libraries documentation. So James has put giving me a nice comment, which I wonder if I can share. No. The Friday night, yeah. So if it's not obvious to anyone else, It is actually Friday night for me. So my Friday evenings, I'm a total nerd, and I hang out at 10 o'clock at night, um, and talk to my computer. So hopefully you won't hate me for that. Uh, I still need to think of a new question. The I and here's one, but I was sort of hoping for an easy question, and this one is another tricky one, which is I would like to see some examples with reborrowing. That is with uh, this kind of weird thing that you see when you are encountering Rust, that ampersand star is actually not symmetrical. uh, the the so I'm just reading more comments. The problem that Rust faces is that, or at least the problem that you face as a learner to Rust, is that let me bring up, I'm just thinking about how to explain this. So, reborrowing is a case where, let me find something online. It's a kind of weird horror. So, it's kind of a strange feature. So, in fact, here is this uh, blog post, which is quite good, that saying that like reborrowing is half baked. Like it's actually not quite enough. And let's talk about the motivating examples, and talking about just the number, and we'll see if we can actually. So I'll post this blog post in the chat, and let's see if we can work through the examples ourselves. The Okay, what I would like to see some examples of reborrowing. Oh, gosh, I wish people would just like say, Tim, how do I compile with Rust? And then I could just say, cargo build, cargo run. It's all fine. Okay, so, but then again, why would you be here if you were just going to do things that are obvious? So I am going to change this. Sorry if this is a bit confusing, but I want to be able to honor the original blog post. And so I'm going to try to emulate it. And the problem that we face is that we want to mutate an integer. We want to increment it. And I'm going to use, I've got a function here, increment. And what it does is it takes an I and let's say a immutable reference to an I32, and it returns a mutable reference to an I32. In the example, it is U32, but actually that's not material. So let's say we want to, let's call it N as well, just to be a little bit more original. And I want to increment it by 1, and then I want to return N. And let's say that I want to create a second magical function called add2. I want to add 2 to N, and that involves creating a method, a function that takes an I32, a mutable reference to an I32, and returns a reference. And to do that, we just we think, I've got this great function that I've already defined called increment, and so why don't I just increment twice? Aha, I say, wonderful. And just to be a little bit different to the poster, I'll change it very slightly, just in case you haven't seen much Rust. I don't want to confuse you with the fact that there's a difference in semantics between uh, excluding the semicolon and not. That's another topic which I will try to not get distracted by. Okay, so now I want to create my variable a, and I'll need to define it as mutable. And then I want to add to. So I've got my add to function, and I need a mutable reference a to a. And then I suppose the natural thing to do is to print this thing out. Okay, I get 44. Awesome. Okay. And we think, okay, we're done. We're finished. And the the problem is that, well, at least one of the problems, at least highlighted here, is that this mutable reference to a t, in which case our t is an I30, an integer of 4 byte, that's 4 bytes wide, is neither copy nor float, nor clone, which is actually an important characteristic. We don't actually want things like the whole point of Rust is to avoid kind of copying these things. But how is it the case then that our second call to, in our case, it's increment, but in the blog posts it's mutate? Like, why does this work if we're saying that it's neither copy nor clone, and isn't that a bit weird? And so it turns out that the compiler has been smart. The compiler has actually added a reborrow. Now, what does and so what's actually happening in, and I think an increment, or I'm going to embarrass myself. No, yeah, it's definitely an increment. Is we create a this is going to sound stupid, but we reborrow the original data again in a different scope, and that now enables us to use it in a different way. So let's actually cause the problem and like unpack it like the blog post does. So if I don't worry, if I ignore all of this, I'm probably going to get myself lost, which is embarrassing. But luckily, there's only 15 people or something watching. It's not like this is the public internet and this could never be sort of recorded. Let's create our magical other so let's break the rules of Rust and create a second mutable reference to a. Oh, actually, it's actually, I'm getting myself all tangled up. I'm going to call this num, just like the original blog post, and then there's two references, A and B. A is a mutable reference to num, and B is kind of like a clone of A, even though they are not allowed. Because they, and so it's kind of this weird problem in a way. It's so odd that you shouldn't be allowed to create B. That's the intuition that we kind of want to push here. And if I compile and run, I get 42, which probably means that I have cached, not pushed save. It compiles after a few warnings about unused code, and then I get the answer 43, which is kind of what I expected. So Rust was able to just basically ignore B, but it was still legal code. So what can I do here? Can I increment twice? And actually, I'll add 10 so that we definitely not. I'll comment this out. Bang. Okay, good. We broke the code. We've got a second. When we tried to actually use that second borrow, the B, it blew up. I wonder if we change things around and it works fine. So what's happening here? This is kind of really odd, is it not? And the other thing that's kind of annoying is, and that this kind of happens implicitly in places. There are some instances in Rust that provides what a lot of people describe as kind of implicit control flow, and that's annoying. The deref trait is one of those places. There are a couple of others that mean that even though Rust doesn't have like implicit casting of integers, for example, or it still has some places that are kind of odd. And the okay, so what have we got here? You can't. Okay, I'm just going to read the post. The thing is, one of the problems is that you can't really express reborrowing in the type system. Oh, wait. This is an argument. The author is saying that, you know, this type of pattern is going to always be sort of slightly broken. But what have we got at the end? That it just feels really clunky. Now, this is sort of an explanation of like what a reborrow is, but it isn't an explanation of what a like reborrow is good for. Now there is a crate that might shine some light on that problem or like that question, and it is conveniently named reborrow. The it might actually provide some kind of motivating examples that we have our object. In this case, it's just a 0, and we want to be able to mutate something even though it has been moved. We want to be able to mutate something even though it has been moved out of scope. So what reborrowing should enable you to do is kind of keep an object alive such that you can actually continue to mutate things, even though the semantics of Rust should mean that the mutable the mutable reference that you created initially should be at the end of its scope. Let's all these. This is not a simple example. This is all kind of yuck. Um, I'm just going to go back to my chat and check to see whether or not I should carry on talking about this, um, and see if anyone is interested in listening. Okay, so so the question that guy wants me to answer, which is that, um, so which I think is quite a reasonable one. So, in this order, the compiler determines that B has reached the end of its lifetime, so it's okay for A to be mutable again. Right, that's exactly what's happening. So in this latter, just in case you've just joined the stream, if I swap the order of execution between these two, notice here that if I'm going to get this wrong, but A lives here, and B lives here. Because the lifetimes are because the lifetimes are kind of overlapping, Rust is not happy. Um, A is still kind of active. But if I can use B while, like, inside, if I move this across, oops. So if I kind of finish up with B before I need A again, then I get this hole where Rust can reason about the aliasing rules and realize that even though the even though A normally wouldn't be legal to be used, the in this case it'll be fine. And one thing to note potentially is that there's only ever one actual reference. This B thing is actually sort of fake. It's only there in the source code. There's only one pointer. It just happens to be the case that we give it a new binding, and the ownership rules are happier in that way. Okay, cool. If people need to drop away for any reason, that's absolutely fine. I am also happy to answer any further questions. Oh, and there's a good follow up question actually. So I am at a bit of a loss as to uh, why you'd want to reborrow. I'm going to be speculative here. I think the reason why a person may wish to reborrow is that you want to be able to kind of extend the utility of your reference. You want to be able to use it in more. Or the Rust. This is going to sound silly if you are really frustrated with Rust. But the compiler engineers that designed the language want it to be as ergonomic as possible. Quite genuinely, they really do care about people's developer happiness, right? You as an individual, and having to, and so that's the motivation. This reborrow feature enables you to use a mutable reference in places where, strictly speaking, it would probably be a breach of the lifetime ownership rules. That's my understanding. So we had a really, this is quite an interesting conversation, a follow up. Um, is it because when you pass a mutable reference into a function, you're essentially moving that particular reference? Essentially. So I think this is the. So let's create a function again. So remember I had increment. So let's recreate increment, and I want to increment n, and I have a mutable. It accepts some immutable reference to n, and I wish to do this. And in this case, I'm going to increment it sort of in place, but not actually return a value. The what we mean, I think, what's meant here by move that particular reference is that we can only have one reference to, in our case, n. So if I want to, if I get rid of all of this, and I have my num, I should give it a proper variable name, like the meaning of life. Is it life, the universe, and everything? I don't remember the exact phrase. But I wish to increment the meaning of life. And this will at first fail, and let's fix that. And saying that I need a reference, or at least I need a mutable. Actually, let's use the terminology. We need a shared reference, so we should mutably borrow, which is a very technically precise way to go to talk about things. Okay, so now we're happy. Okay, so let's create R. And R is our mutable reference to the meaning of life. We can pass R here. And the question is, what is the lifetime of R? And could you and how long, like, there was like the R, this R variable should only be allowed to exist while there is something that actually is available. I wonder what would happen here if I force Rust to drop the value, and then I try to kind of use R. So essentially, line 28, R is like, it's referring to nothing. Okay, good. We haven't broken Rust. We haven't detected. It's saying that you've given ownership. So you've basically sent the ownership of this meaning of life variable into drop, and then later on through R you're attempting to access it again, and that is illegal. So sorry, Tim. Now the so yes, it essentially is that you move the particular reference that you. I wonder if we could pass. So one thing that we could do would be to kind of create a thread and then send our reference into multiple places, and so we'd have two references to the same object. What you'll find is that Rust will prevent this. It's not going to allow you to create two things that exist. I mean, safe rust isn't going to allow you to have two references to an object or to some value with the ability to change the value. If we want to, we can break the rules. Um, for example, one of the things that we can do is note that R is just a number. It's just a pointer, and we can actually go and just like treat it as we can cast it as like a U64 and then just like create more U64s and then create new pointers, and then we have 5 of them. But then we're breaking essentially we'd have to actually dereference the values. We then need to unsafe. And I don't know, I'm just going to clap a little bit because we've just had someone understand something, which I think is really awesome. And I can't see because it's too dark, but I'm going to click on some emoji, I think, and I maybe just type clap and see if it does it. So there we go. I'll clap. Oh, gosh. There we go. And now we had some really good questions around the around like why would you like what can't you actually do if you didn't have reborrowing. And I think what my answer would be is that you probably would just find the syntax clunky. You'd have more compiler errors and you'd be frustrated because you'd have to copy things a little bit more explicitly. And I'm interested in kind of other people's views as well. Yeah, okay, fantastic. The um, I'm just kind of scrolling back through the chat. There's some really good discussion, which I'm really, really excited by. Like, it's actually really cool to get people talking and all the rest of it. So, hopefully, the reborrow discussion has been somewhat useful to people. And how about are there any more? Are there any more other questions that people would like me to chat about? I really, some times like this, by the way, I always feel as though I wish I knew how to speak more languages. Like, I'd love to be able to speak Polish. I think the problem that I have as an English speaker, just specifically around Polish, is that I'm terrible at the pronunciation. I think English speakers in particular always put the emphasis on the wrong part of the word, and so it sounds really really terrible. When I attempt to speak Russian, I do a very bad job. um, Not to say that the Polish and Russian are the same language, or because I know that the Poles hate the Russians, but I have attempted just to speak more than English. Um, and by the way, so it looks like I'm just noticing that we're kind of wrapping up. So I'm going to pause. I think actually hold the. I'm going to end the stream now. I think we're hitting 58 minutes, which is a good amount of time. If you have enjoyed the discussion, I thoroughly recommend subscribing to the channel. I am looking to do a similar thing more regularly. It will be more structured next time. I think I will have an actual tutorial to go through rather than just answering questions on the fly, which is, I think, a bit stressful for everybody. But in particular, it's stressful for me. So I'm going to give everyone my. If you click in the description of the YouTube channel, you'll see a couple of links to connect with me, and hopefully we will see each other online. Okay, take care. Bye bye.